The topic is ratios and rates. The objectives in this topic: write ratios as fractions, write rates as fractions, find unit rates, and find unit prices. A ratio is a quotient of two quantities. A ratio can be written in three ways. It could be written with the word two, it can be written as a fraction, it can be written with a colon between the two numbers. All three are read 1 to 2. So that's not read 1/2 when it's a ratio, it's read 1 to 2. The order of the quantities is important when we're writing ratios. To write a ratio as a fraction, we write the first number as the numerator and the second number as the denominator. So 1 to 2 is always 1 as the numerator, 2 as the denominator. Let's write the ratio 15 to 23 using fractional notation. This is easy peasy and, dare I say, lemon squeezy. 15 to 23 is 15 to 23. First number on top, second number on the bottom. And a ratio is given like this: 5 to 9, or 5 to 9. We want to write these ratios as unsimplified fractions. That makes these really easy. 5 to 9, 5 to 9. Do not simplify. You couldn't anyway, but we're not gonna. 4 to 3. 4 to 3. Write it as a fraction. Don't simplify. 20 to 222. Oops, I forgot to write the problem. 20 to 222. But it's so easy. Just take whatever you're given, write it as a fraction, do not simplify. Since we're not simplifying, we're allowed to have all those weird things. 7.1 to 9.1 is 7.1 to 9.1. You might go, but you said we can't have decimals in fractions. Well, I said that we can't when we're simplifying. And here we're not simplifying. 2 to 9 1/3 would be 2 to 9 1/3. We just write it as a fraction. We don't simplify. 9 1/2 to 6 1/5. 9 1/2 to 6 1/5. That's all there is to it. Simplified ratios. 16 to 40. If we follow what we did last time, then our strategy would be to write it as a fraction. What difference is there going to be between a simplified fraction and a simplified ratio? Well, it turns out not much. And the first time we get to something different, I'll bring it up. But right now, let's just go ahead and reduce the fraction. They're both even. So that means they both have a factor of 2. 16 is 2 times 8. 40 is 2 times 20. 2's cancel. 8 and 20. 8 is 2 times 4. 20 is 2 times 10. 2's cancel. 4 and 10. 2 times 2. 2 times 5. The 2's cancel. Our simplified ratio is going to be 2 to 5. Notice I'm not saying 2/5.
2/5 is a fraction. 2 to 5 would be a ratio. They look the same. They're said differently. 2/5 would mean 2 out of 5. 2 to 5 means 2 parts of one thing to 5 parts of something else, not 2 out of 5. Let's find the simplified ratio for 8.1 to 10. Well, we start with what we did last time, right? The unsimplified ratio. And then we have to deal with this when we simplify. Just like a fraction can't have decimals inside of it, a simplified ratio can't have decimals inside of it. We can get rid of the decimal on the top by moving it 1 to the right. But that means we're going to have to do the same thing. 10, which is 10 decimal point. That decimal point would have to get moved 1 to the right. We have 81 to 100. This does not reduce. It is our simplified ratio. Another one. 9.45 to 9.43. Set it up as a fraction. 9.45 to 9.43. We got to get rid of these decimals. We can do it by moving 2 on the top. 2 on the bottom gets rid of the 1 on the bottom as well. 945 to 943. This time I'm going to include some units. 15 inches to 25 inches. Let's write it as a fraction. Include your units. 15 inches to 25 inches. And notice we have inches on the top, inches on the bottom. Those are going to cancel away and the units are gone. A ratio will not have units because the units will always cancel. Now we have to deal with reducing the 15 over 25. 15 is 5 times 3, 25 is 5 times 5. The 5s cancel. Our simplified ratio is 3 to 5. Another one. Hopefully this isn't too difficult. Any difficulty you're experiencing right now would have to do with reducing the fractions. And that's something we are long past at this point. If you're struggling with reducing fractions, I urge you to seek out tutoring. We have many tutoring options. 16 hours to 50 hours. Start by writing it. 16 hours to 50 hours in fractional notation. The hours cancel away. Ratios will not have units. They will cancel away. Leaves us with 16 over 50 to deal with. They're both even. They can both be divided by 2. 16 is 2 times 8. 50 is 2 times 25. The 2's cancel. We're left with our simplified ratio of 8 to 25. Another one. $26 to $100. Just because it doesn't say dollars afterwards and I'm writing the dollar sign instead doesn't mean that the dollar sign is not units. $26 to $100. The dollar sign, the units cancel away. 26 is 2 times 13. 100 is 2 times 50. The twos cancel. We're left with the final simplified ratio of 13 to 50.
Now we're going to add the condition, write the ratio as a fraction in simplest form. That means that we would reduce the fraction looking ratio. $25 to $15 would be $25 to $15. First over second, first to second. The units are the same, so the units cancel away, leaving us with 25 over 15. 25 is 5 times 5. 15 is 3 times 5. 5's cancel, leaving us with 5 over 3. 5 to 3 would be the ratio as a fraction in simplest form. And with ratios, the units will always be the same. The units will always cancel each other out. If they don't, then instead of a ratio, we'll have a rate, and we'll talk about that in a little bit. Let's write the ratio of 2.6 to 3.1 as a fraction in simplest form. 2.6 to 3.1 as a fraction, 2.6 over 3.1. Now, we need to multiply by some form of 1 to get rid of the decimals. We can't have decimals inside of a fraction if the fraction is in simplest form. Sort of like when we're dividing decimals. We can't divide until we have a whole number on the bottom. With decimals inside of fractions, we can't be in simplest form until everything is a whole number. So here we need to basically move the decimal points 1 to the right on the top and on the bottom. That's multiplying by 10 over 10. That'll give us 26 over 31. Or you can just think of it as moving the decimal point the same number of spaces on the top and on the bottom until you only have whole numbers. And then 26 over 31 does not reduce any further. Just like we can't have decimals inside of fractions, we can't have fractions inside of fractions. So when we set up the ratio of 1 1/5 to 2 7/10, that's 1 1/5 over 2 7/10. And since it has to be in simplest form, if we didn't have the in simplest form in the instructions, we're good. That's a ratio. But in simplest form, we have to get rid of the fractions, which means we need to turn this into a division problem. And remember, to divide mixed numbers, we need them to be improper fractions. So improper fractions would be 6/5 divided by 27/10. And then dividing by a fraction is multiplying by the reciprocal. So 6/5 times 10/27. 6 is 2 times 3. 10 is 2 times 5. 27 is 9 times 3. 9 is 3 times 3. So if we break it up as far as it'll go, get the prime factorizations for everything, we'll see that a pair of 3's cancel and a pair of 5's cancel, leaving us with 2 times 2 over 3 times 3. That's 4/9. So the simplified ratio is 4/9.
I'm going to throw a ringer at you. 1 month to 24 days and I'm going to provide you this extra instruction for the purposes of this problem. One month equals 30 days. I know sometimes a month has 28, 29, 31 days instead. For the purposes of this problem, 1 month is 30 days. Why am I using this extra instruction? Why am I pointing this out that it'll be necessary? Because for ratios, remember, the units will always cancel. And if we go 1 month to 24 days, we have an issue. The units don't cancel, they're not the same. We would need to convert one of the things we're given so that they do have the same units. So instead of 1 month, we would replace that with our given 30 days. We'd have 30 days over 24 days. And now days cancel. And now we're dealing with 30 over 24. Both of these can be divided by 3, 3 times 10, 3 times 8, the 3's cancel. We're dealing with 10 over 8. That's 2 times 5, 2 times 4. The 2's cancel. We're left with the final simplified ratio of 5/4. So 1 month to 24 days would simplify to the ratio of 5/4. For our next one, we're not going to have to do anything fancy. Let's do 39 days to 24 days. Nothing fancy. 39 days to 24 days. Days cancel. We're good. We have a ratio now, no units. 39 to 24. Both of these can be divided by 3. 39 is 3 times 13. 24 is 3 times 8. The 3's cancel. Our final simplified ratio, 13 to 8. Next up, five and a half to 9 5/8. Last time when we were doing unsimplified ratios, we just did 5 1/2 to 9 5/8, and we said that's it. That's all we have to do. Unsimplified, fun, easy. Nothing else needs to be done except putting one over the other. Simplified, not so easy. We need to keep going. When we were dealing with simplifying fractions, that might look like mixed number over mixed number. We knew that mixed number over mixed number meant mixed number divided by mixed number. And we have to do the same thing here. How do we divide mixed numbers? We need to change them to improper fractions. So this is 2 times 5 is 10 plus 1 is 11 halves. times 8 times 9 is 72, plus 5 is 77/8. Oh, not times, still division. My bad. It's not multiplication until we change it in the next step. Keep the first, change division to multiplication, flip the second. 11 and 77 can both be divided by 11. 11 divided by 11 is 1. 77 divided by 11 is 7. 2 and 8 can both be divided by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 1 times 4 on the top. 1 times 7 on the bottom. 4 to 7 is our final simplified ratio, our ratio in simplest form. Again. And remember, I said, if we're ever going to have a difference between a simplified fraction and a simplified ratio, I'll point it out when we get there. At the end of this problem, we will have gotten there. There will be something different than simplifying the fraction. 9 and 6/7 hours, 9 and 6/7 hours to 1 and 2/21 hours. Take the first one, put it over the second one. Units cancel away. We want that when we're dealing with ratios. No units. So we have 9 and 6/7 over 1 and 2/21, just like we just did. That is a division problem. 9 and 6/7 divided by 1 and 2/21. 7 times 9 is 63 plus 6. That's 69/7 divided by 21 times 1 is 21 plus 2, 23/21. We turn it to multiplication. Keep, change, flip. 7 and 21 can both be divided by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. And this is still nothing new. 23 and 69. These can actually both be divided by 23 because 23 times 3 is 69. 2 times 3, 9 times, 2 times 3, 3 times 3, 23 times 3. So 69 divided by 23 is 3. 23 divided by 23 is 1. Here is where the difference is going to come in. This is 3 times 3 over 1 times 1, which is 9 over 1. Normally, we would have to divide that if we were just simplifying the fraction, and our final answer would be 9. However, a ratio needs to have a top number and a bottom number. So the answer is 9 to 1. An answer of just 9 would be incorrect. It has to be 9 to 1. Because this is a ratio, not a fraction. It looks like a fraction. It works like a fraction. Except if we have over 1, we wouldn't divide because a ratio needs to have a top and a bottom number. Otherwise, it's called something else. And we're going to get there. We just have a few more examples of simplifying ratios. Hopefully you've enjoyed today's class so far. Because of the fact that there's been nothing new except that last little bit about how 9/1 would stay 9/1.
Given this rectangle, 7 feet by 5 feet, let's find the ratio of its width to its length. Well, the length implies longer. The length is 7 feet. The width is 5 feet. So width to length would be 5 feet to 7 feet. Feet cancel, leaving us with 5 to 7. Again, length implies longer. Find the ratio of its length to its perimeter. Length to perimeter, we need the perimeter. The distance around, add the sides, 2 sides of 7, 2 sides of 5. The perimeter is 24 feet. The length was 7 feet. So 7 feet to 24 feet, feet cancel, 7 to 24.
Copy along with me. A mural measures 125 feet long by 170 feet high. Find the ratio of the height to the perimeter of this mural. While you're copying, I'll read it again. A mural measures 125 feet long by 170 feet high. Find the ratio of the height to the perimeter of this mural. As we get into more wordy problems today, if you are the type of person that approaches a word problem by just pulling numbers out and doing whatever to them, you're not going to get them right. So if you look at this and you see the 125 and you want to write 125, and then you see the 170 and you want to write the 170 and you reduce from there, that is wrong. Don't do that at all. Step 1 of a word problem is read it. Step 2 is understand it. You need to have reading comprehension. What are we looking for? What is the question asking for? Find the ratio. Good, we're doing a ratio. Boom, ratio. Of what to what? Height to perimeter. Height to perimeter. Okay, what's the height? Is it the 125 long, or is it the 170 high? It's the 170, 170 feet. Put your units in. Okay, so what's the perimeter? Is it the 125? Nope, that's the length. They don't give us the perimeter. We need to find it. And we can do this. Let's draw the picture. Measures 125 feet long by 170 feet high. How do we find the perimeter? We add the sides. Okay, I had to plug in so that we didn't lose power to the overhead projector. As I was saying, how do we find the perimeter? Let me give myself more room. We add the sides. So we're going to add 125 plus 170 plus 125 plus 170. I'm going to change the order so I can add better, but you can add them in any order, however you want. $125 plus 125 is 250. 170 plus 170 is 340. And 250 plus 340 is 590. Perimeter keeps the units. Feet. So this is 170 feet to the perimeter, 590 feet. And now we can go ahead and simplify our ratio. Let me get rid of all this. Feet cancel. You can also cancel a 0. Divide them both by 10. We're looking at 17 to 59, which does not reduce. If we had a basketball court that has a 30 feet width and a 92-foot length, and we're asked to find the ratio of width to perimeter, then again, we can't just be plugging in whatever we got. We have to be careful. The width is 30 feet. The perimeter is not given. We need to find it. So add the sides. 92 plus 92 plus 30 plus 30. 184 plus 60. $244 feet. Feet cancel. They're both even. We can divide them both by 2. 30 is 2 times 15. 244 is 2 times 122. 2's cancel. Our final ratio, 15 to 122. Let's say we had a triangular shaped billboard. That's 3 feet over here and 4 feet over here and 5 feet over here. It's a billboard. And we wanted to find the ratio of the longest side to the perimeter. What's the longest side? That's the 5 feet. What's the perimeter? Add the sides. 3 plus 4 plus 5, 7 plus 5, 12 feet. Feet cancel away. The ratio of the longest side to the perimeter is 5 to 12. Another lesson in reading comprehension incoming. Copy along with me as of 2009. A particular company had stores that operated in 43 states. Find the ratio of states with stores to states without stores. Write the ratio as a fraction in simplest terms. They give us two numbers here. 2009, that's a year. That's not a number we're going to use in our ratio. So we only have the number 43 to make this problem work. We're looking for the ratio with to without. They operate in 43 states. That's 43 states with stores. What number do we put on the bottom? Well, as of today, if there are 50 states and 43 have stores, we would subtract 43 from 50, and there would be 7 states without. 43 to 7. So not only do some of these problems require you to have reading comprehension to pull out the second number, sometimes that second number has to come from outside information that you should know. And you should know there are 50 states. 43 to 7. Okay, so that is our discussion of ratios, which then takes us to our discussion of rates.
Now, I said we'd get to this. A special type of ratio is a rate. A rate is used to compare different kinds of quantities. So 3 miles to 33 minutes. When we reduce that, the 3 over 33 becomes 1 over 11, but the units don't cancel because they're not the same. So we keep the units, 1 mile to 11 minutes. Ten nails every 6 feet would set up the ratio of 10 nails to 6 feet. The 10 over 6 reduces to 5 over 3, but nails and feet don't cancel each other out. We're left with 5 nails to 3 feet. $2,160 for 12 weeks. That would be $2,160 to 12 weeks. It turns out that 2,160 divides by 12 evenly, we get 180. But since it needs to stay a fraction in simplest form, it needs to stay a rate. We need number with units on top and number with units on the bottom. So $180 to 1 week. We don't do that final division. That would be something that's a special type of a rate. So a special type of a special type. That would be a unit rate if we went ahead and divided the numbers. We could say $180 per week would be a unit rate. But we don't want that yet. We're not there. $180 to 1 week. 360 miles on 16 gallons of gasoline. We set up 360 miles to 16 gallons. We reduce 360 over 16 down to 45 over 2. And we have 45 miles to 2 gallons. If we divided that out, 45 divided by 2 would be 22 and a half. That'd be 22.5 miles per gallon as a unit rate.
Rates are going to be ratios that do not have the same units. The units won't cancel when you have rates. So if we have, for instance, 11 shrubs every 44 feet, and we wanted to write the ratio as a simplified fraction, we're going to end up with a rate because the units don't go away. See, 11 shrubs for every 44 feet. Shrubs and feet are not going to cancel. They're not the same. How are we going to deal with this? We're going to separate them. We're going to take the numbers and simplify that ratio, but we're going to have new units. Shrubs over feet shrubs per feet or shrubs per foot. Let's just make it FT, shrubs per foot. $11 and 44 can both be divided by 11. 11 times 1, 11 times 4. The 11s cancel. So this is 1 over 4 shrubs over feet. 1 shrub for every 4 feet. Let's look at another. If a particular store has 45 returns for 300 sales, how can we write this ratio as a simplified fraction? How can we determine this rate? 45 returns over 300 sales. 45 over 300 returns over sales. 45 and 300. We'll just right off the bat, They're both divisible by 3. 3 times 15, 3 times 100, and then 15 over 100. Those can both be divided by 5. 5 times 3 over 5 times 20. So we have 3 over 20 returns over sales. The rate is 3 returns for every 20 sales. $426 calories in a 12 fluid ounce chocolate milkshake. $426 calories over 12 fluid ounces. That's 426 over 12 calories over fluid ounces. $426 and 12 can both be divided by 2. 2 times 213, 2 times 6. 213 is divisible by 3. 3 times 71, just divide to get that. 3 times 2, we have 71 over 2 calories over fluid ounces. 71 calories for every 2 fluid ounces. When we're just talking about a regular old rate or a ratio that includes different units, we will always have the numerical part written as a ratio. But there's a special type of rate called a unit rate.
Why did I bring the unit rate up again? Because we're there. A unit rate is a rate with a denominator of 1, and we get that by dividing. 55 miles per hour is an example of a unit rate. It's a rate that's a single number with a unit that compares to other units.
How many of you have been to Walmart before? I know Walmart has them. Maybe Giant Eagle has them too, but on the price tags, there's price, but then off in one of the corners, there's this orange box that has a different sort of price in it. And if you had a good grandpa like me, someone in your life, explain to you what that is, and that is your comparison price. Because after all, if we have a huge bottle of, say, shampoo, and a tiny bottle of shampoo, obviously the big bottle is going to cost more than the little bottle. So if you're just trying to spend a small amount, yeah, go in, buy the small bottle. But if money isn't really an issue and you just want the better deal, you might want to figure out, well, this big one has so many ounces and the small one has so many ounces. Which one's the better buy? So you could figure out how much the big one costs per ounce and then how much the small costs per ounce. And whichever one's cheaper per ounce is the better buy. Walmart and probably other places, I am trying to think, and I think Giant Eagle has it, it's just not highlighted. They might say something like 3.9 cents per ounce somewhere on the tag. But having these unit rates listed on the price tag helps you so you don't have to be walking around with a calculator trying to figure out what's the better buy all the time. You can just look at the orange box price, compare those, and the smaller orange box price is always your better deal. So we're going to look at how to find these unit rates ourselves. This eraser is going to need a good cleaning soon. How is this different than the rates we just looked at? Well, if we wanted to write as a unit rate 570 calories in a 5-ounce serving, a unit rate will always have us completely divide out the numerical ratio. So 570 calories over 5 ounces, we're going to end up writing this as some number of calories per ounce, a single number instead of a ratio. So 570 divided by 5. We actually divide this time. We don't reduce, we divide. 5 goes into 5 once. Bring down the 7, 5 goes into 7 once. Bring down the 0, 5 goes into 24 times. The unit rate would be 114 calories per ounce, not 114 over 1 calories over ounces, just 114 calories per ounce. Unit rate, unit, single number. We're going to write it as a whole number or a decimal. Let's do another. We're looking for the unit rate again. If there's 497 riders in 7 subway cars, 497 riders per 7 subway cars, the unit rate is going to tell us how many per 1 subway cars. Some number of riders per car. How do we get that? We divide. 497 divided by 7. 7 goes into 49 7 times. 7 goes into 7 once. So 71 riders per car. Unit rate, single number, single car. How many riders per single car? 71. A hummingbird moves its wings at a rate of 5,520 wing beats a minute. Write this rate. How many? Question mark. It looks like a 3 with a dot. Question. How do I all of a sudden become unable to write a question mark? What is this rate in wing beats per second? Oh no. Okay. This thing I'm about to teach you is technically called dimensional analysis. You learn it in science classes. Really, it's unit conversion. We're given 5520 wing beats, and that is per minute. So for every 1 minute. We want our answer to be some number of wing beats per second, but we have wing beats per minute. We want to multiply by some conversion. And remember, we cancel things that are the same on the top as on the bottom. We don't want wing beats to change, but we need to turn minutes into seconds. We need to get rid of minutes. So to get rid of minutes on the bottom, we need minutes on the top. What do we want to change it to? We want to change it to seconds. So we need seconds on the bottom. So now you have to pull from what you know. Minutes and seconds. What do you know about those? How many and what? What would you say? Okay, so hopefully you just said there are 60 seconds in 1 minute. 60 seconds in 1 minute. Now, minutes have canceled and we're left with wing beats over seconds. To get our number, we need to do 5,520 divided by 60. And that'll give us wing beats per second. I want to go ahead and give myself more room because I have to do 5,520 divided by 60. 60 doesn't go into 5, it doesn't go into 55, it goes into 552. I know 60 times 10 is 600, 552 is close to 600. What's 60 times 9? That's 540. That does fit. At 12, I bring down the 0. 60 goes into 120 twice, evenly. $5,520 wing beats per minute is 92 wing beats per second. Still looking for unit rates. $500,000. Lottery winnings paid over 40 years. $500,000. We'll put that over 40 years. Our unit for our unit rate is going to be dollars per year. Dollars per singular year. 500,000 divided by 40. 40 goes into 50 once. 40 goes into 100 twice. 40 goes into 200 5 times. The 2 zeros are going to come down. 40 will go into the first zero brought down 0 times. 40 will go into the second zero brought down 0 times. Basically, we're just filling in zeros to finish off the number. The rate is $12,500 per year. Suddenly winning $500,000 when it's paid out in an annuity and you get $12,500 per year, that's before taxes. Doesn't seem so great, does it? You wouldn't even clear $1,000 a month. Let's find another unit rate. $12,000 good products to 30 defective. Well, 12,000 good to 30 defective. 30 defective. We would have 12,000 divided by 30. 30 goes into 120 4 times. 30 goes into 0 times. 30 goes into 0 times. So this would be a unit rate of 400 good to defective. In other words, for every one defective product, there were 400 good, or for every 400 good products, there was one defective.
So $31,500 every 7 months would be $31,500 to 7 months. To get it in dollars per month, a unit rate, we would divide 31,500 by 7. We get 4,500. So the unit rate is $4,500 to 1 month, or $4,500 per month. If a unit rate is money per item, then it's also called a unit price, a special type of a special type of a special type. The unit price is the price divided by the number of units. So a store charges $4.80 for a 32-ounce container of laundry soap. What is the unit price in dollars per ounce? Well, it even tells us the order to divide. It says in dollars per ounce. That's dollars divided by ounces. $4.80 divided by 32 ounces. When we divide 4.8 by 32, we get 0.15. So 15 cents per ounce. Approximate each unit price to decide which is the better buy. 4 bars of soap for 99 cents or 5 bars of soap for $1.19. Now, the reason it says approximate is because we might have to round to the nearest cent. Doesn't mean to go ahead and round the numbers. So let's divide 99 cents to 4 bars, or $0.99 to 4 bars. We divide 0.99 by 4 and we get 0.2475, or about 25 cents. If we divide $1.19 by 5 bars, we get 0.238. So 23.8 cents, or about 24 cents compared to the about 25 cents. It's about a cent cheaper to get the 5 bars of soap for $1.19. So the 5-bar package is the better buy. And that is it for this topic.